This is a Technics SE-A7 power amplifier. I have this on my bench for restoration. I'm going to bring you guys through the work that I do because I know my last few videos on restorations have been getting a lot of views and a lot of positive feedback, which I really appreciate. But getting back to the SE-A7, I bought this about a month and a half ago out of more of a curiosity than anything because I really never see these amps come up on the market. And I hear really good things about the SE-A5 and the SE-A3, which are this amplifier's bigger brothers. And as you can see, this amplifier is quite small. It's only one rack unit tall. It puts out about 60 watts per channel into 8 ohms, but after hearing it, even on speakers like Vandersteen's, it's very, very impressive. It's definitely got a lot of dynamic headroom, which is pretty funny because it only has 2 output devices per channel and 20,000 microfarads of filter capacitance shared between those 2 channels. What's cool is it has 2 transformers, which actually probably helps out a lot with the headroom of the amplifier. I never really see one rack unit tall hi-fi amps, and especially not ones that are basically dual mono. So the restoration work I'm going to do on this amp, it's pretty basic. I'm just going to do a full recap. This amplifier uses Matsushita capacitors, which are known to get actually physically leaky and corrode boards and traces and nearby components. So those are going to get thrown out and replaced with new, probably Panasonic and Ichicon replacements. The 2 filter capacitors I'm also going to change out for Kemet equivalents of higher voltage rating. I might go from 10,000 each up to 12, but that depends if I can fit them in here. Technics actually mounted them horizontally just so they could fit them in the chassis, as again, it's only one rack unit tall. Other things I'm going to do, I'm going to change out the RCA jacks, and I'm definitely going to change these out. These are bare wire only terminals, so you have to turn them a quarter of the way, and it basically locks the bare wire into there. And they're really gritty, and they're just not nice to use. So those are going to get replaced with these banana terminals. I don't have a ton of room to work with back here, so that's why I'm going to use these. I'm going to have to make a blank plate right here and mount it to the back with the screw holes that are provided, and solder them to the main board. The other thing I'm going to do is I'm going to put an IEC inlet on the back. I have an IEC inlet right here. This is a filtered IEC inlet. So I'm going to take this old style lamp cord off and take this pass-through outlet off, and this is probably where I'm going to mount the IEC right here. So let's take the top cover off and let's take a deeper look inside. I should have all the parts I need other than the filter caps, so this shouldn't be too long of a restoration. Although there are a lot of parts that need to be changed, and there's a lot of solder joints on the main board, and the few daughter boards that are in here, they have to take those out as well. So let's take a look. Here's the SE-A7 with the top panel removed. I have some tape over the top of the faceplate to stop any scratches from happening. So you can see that Technics pretty intelligently laid this amplifier out so they could fit all these components in such a small enclosure. So that's why you don't have a lot of room to move stuff around, and you know, there's really no free space in here except for back here, which is going to be nice for the IC inlet. So starting from the left, you have your left channel right here, and again, only 2 output devices per channel. So these are your main outputs, and then you have your drivers here. They used a Freon heatsink. So instead of using a large thermal mass heatsink, which would be too large for this enclosure, they used basically a copper tube filled with Freon, and they used this shave fin heatsink style right here for more efficient cooling in a small space. Here's your 2 transformers right here, 1 for each channel. They're pretty solid. These are potted. I think these are either R-core or Toreto transformers, as EI transformers wouldn't really fit into a shallow chassis like this. Basic things like your power switch and your headphone jack up front. And here's your speaker terminal board and things like your input, for your RCA and your bridge tie load switch right here. That's going to be pretty interesting to take this out and have to retrofit those binding posts, because I don't know if you can see this, but they have those assemblies screw to the back panel, and they have them directly soldered to that board, so it's going to be pretty challenging to deal with. Toward the front, you have your switches for meter range and your remote and main speakers. Here's your drive circuit board for your VU meters right here, your VFD meters. Here's your power relay and your output relay. I think this power relay controls the bridge state, so it'll change the power supply voltage for your bridge tied load operation. Here's your rectifier right here, and your 2 filter caps. These are 10,000 at 56, so they're pretty small, especially for being shared between 2 channels. Which again is really funny, because the bass performance on this amp, even with low impedance loads like Vandersteen's, is just crazy. I wasn't really expecting it. So yeah, these are gonna get changed out. And just things like these Matsushita capacitors, these all like to leak. And I think one of them's already leaking right here. Yeah, that one's starting to corrode. And Technics, in their infinite wisdom, started to use corrosive glue, and it's already starting to corrode components. So I got to pull these 2 boards out, and this board back here, because when they soldered these boards in, they used that glue to kind of anchor them down, and it really screwed with the components, and there's going to be more shit to deal with. So I'm going to pop the bottom panel off and start pulling these boards out and start reworking them, and I'll give you guys an update as I go along. So here's the first board I just removed from the chassis. I also have the faceplate off, and I have the VFD display removed, and that's over here. This board was glued in, so I have to scrape all this glue, and I'm going to reflow and deflux it as well. Lots of glue everywhere. It's going to be kind of a pain to deal with. So here's that same board, completely reflowed. I still have to deflux it, and I'm still going to change out the 2 variable resistors for new Bourne's trimmers. Those are both 10K. I have the glue scraped from it as well. Next up is this board right here. Lots of glue on this one as well. I have all the main boards removed from the SE-A7, except for the filter capacitor board and the input-output board. I have them all right here. I reworked every single one of them. New capacitors, I scraped the glue, and I reworked the boards as well. And defluxed them. So they all look pretty good. Here's the old parts that I changed out. Just some caps and some trimmers. And with a couple of these caps, you can actually see where they started to leak. They're starting to corrode. And I have one of those caps over here hooked up to my Sencor analyzer. You can see this one got leaky too. It's a 16 volt at 47 microfarad capacitor, and it actually measures okay. Even the ESR is okay. And capacitor leakage is low as well. So even though it's not electrically leaky, it's physically leaky, so it's got to be changed out, just like the rest of the caps. And here's the rest of the parts I have to change. So these 2 potentiometers are for the bias. I have just a bunch of caps, and I also have the rectifier diodes. I'm changing those out for much better parts, which are right here. And I haven't scraped the glue yet. That's what I'm about to do. And then I'm going to recap it, put the boards in, and adjust it, and then I'm going to move on to the rear section. So stay tuned. So I found the best way to remove this tricky glue that just kind of sticks in place and doesn't want to come off without scratching the circuit board. The best way to remove that is to hit it with some freeze spray. And then after that, it just flakes right off. So I've made quite a bit of progress since I recorded the last video segment, so I felt like I should update you guys on what's been happening. The last I took a video of, I showed you these circuit boards right here. These are all complete. Here's my filter capacitor board. It's just waiting for the new caps that are coming. I ordered Chemet filter caps in the same size as the originals. And here's my VFD board. I have a couple capacitors on this changed. It's about as much as I want to do. I don't want to disturb the VFD. That's the last thing I want, is to have this VFD die, as these are very sensitive. Here's some of the old parts from those boards. Just your typical leaky Matsushita caps, your carbon trace trimmers for your impedance sense and your bias. And here are the old rectifier diodes. I changed those out with much better replacements. And here's the main board. I have it completely recapped with Panasonic FC and Nichicon KL series capacitors. I also have some Muse and maybe a couple others around. The next step I have to do is I have to reflow this board, and I'm gonna partially deflux it. It's kind of an awkward setup to deflux. It's probably gonna make more of a mess than it's gonna clean up. So I'm probably just gonna deflux certain areas that need it, like these right here, these joints. So other than that, just the basic stuff like glue removal. So I'm gonna remove this assembly next. There's a couple capacitors that they have hanging off the board in the wire loom there because they couldn't fit them on the board originally. So stay tuned. Here's a left output module. This just unscrews from the chassis and you can rotate it up like that and work on the back of the board. I'm gonna reflow the board, make sure the ground screw is tight. I'm gonna redo the thermal interface between this aluminum sink and the heat pipe where the transistors are mounted to, and change out these two capacitors. They have these kind of flying off the board. I guess they're trying to get them away from the heat sink, but with the new capacitors I'm putting in, that won't be a big deal. I'm putting in a 105C rated cap, so change those out, scrape the glue, and then I'll reinstall this in, and then I'll move back to this board and I'll start the reflow process on that. Okay, real quick update here. I have the thermal interface redone. I just have to remount the heatsink to this thermal spreader. I have this board recapped and reflowed. And other than that, this is about to be ready to put back in the chassis. And then I have to take this one off and do the same thing. This is really important as the heatsink is pretty small. You want the best thermal interface you can get between the two output transistors and this heatsink. What I use is I use a toothpick to apply the heatsink compound. I find that's the easiest way to do it. So I'm gonna get that reinstalled and I'll follow up this little clip with another one as soon as I'm done with that side. Here's a quick shot of the main board. I just reflowed it and I defluxed it. And the finished product is very nice. So I'm gonna reinstall these daughter boards onto this and move to the back panel and start dealing with these output jacks and the input jacks and the IC inlet. Okay, so I have the SE-A7 put back together for the most part, except obviously the front VU board and the front panel. I have my original filter caps installed just temporarily until I have the Chemet capacitors come in. And I'm following along the service manual for my bias and offset adjustments, just to make sure everything's working properly. Quick side note, this service manual is awesome. They give you a detailed view of the amplifier and every single trimmer and test point that they want you to adjust with. Even illustrations like this. They're just very helpful. So good on you, Technics, for doing that. That's a nice service manual. So right now my offset loaded down with 8 ohms. It should be plus minus 30 millivolts. And right now I'm sitting at negative 1.5 basically. So that's perfect. And my bias should be 1.5 millivolts, and we're sitting right at about 1.5. As the amplifier heats up, it'll all stabilize. So it's been on for about 10-15 minutes now. So that's a pretty good sign. And my right channel is identical. So everything on the right channel is measuring well, just like the left. So I'm gonna let this run for a little while longer, and I'm gonna move on to the rear panel. I'm gonna get the outputs changed out for binding posts and get the RCA jacks changed out as well. And then I'm gonna do my IEC inlet last. So I'll come back with a quick video when I move on to the rear panel. But for now, everything's measuring well and it's looking good. So I'm back with the Technics SE-A7. The last video I took, I had just finished the circuit boards and I was moving on to the rear panel. So I just finished that job. As you can see, I changed out all the spring clips with new banana jacks on the back. And these are nice because they're so low profile. I was able to work with them pretty easily. Let me flip this around so I could show you the metal panel that I had to fabricate. I don't know how well you're going to be able to see that, but if you look in there, you can see an aluminum plate that I fabricated and I drilled. And that is screwed to the rear panel, and then these posts are then put through that, and then they have a nut on the back side that holds them on. And then what I did was I soldered a wire from the terminal to the circuit board on each one. And then what I did was I reworked the circuit board and I defluxed it. And I also polished the rear RCA jacks. I was going to change those RCA jacks out, but as it turns out, that they're actually an anchor point for the circuit board. So these two jacks are soldered to the main board, and the RCA jack assembly is screwed to the rear panel. So it gives this circuit board kind of an anchor point, which I didn't want to disturb. So they're fine anyway. They look good, and they polished up pretty nicely. And the last thing on the back I did was I ripped out the old lamp cord and I installed a new IEC inlet. This is a filtered IEC inlet, and I have the wires from the amp soldered to it with some heat shrink. And I have the old hole for the old lamp cord plugged up, so it gives it kind of a factory look. There's no gaping hole in the back panel now that a lot of people just usually leave in place. I actually have it covered, so that looks nice. Yeah, just to show you, this is a banana jack that fits into these terminals quite well. It's a nice fit. So these are pretty high quality jacks, and these are actually pretty cheap. So I picked up a bunch of those. The next step I'm going to take is I'm going to change out the filter caps. So here they are right here. I put these back in just so I could test the amp, make sure there's nothing wrong after I did all that work to it. So I'm going to put these in. These are an exact replacement. They're a little shorter, but that should be fine. They're a higher voltage rating at 63 versus I think the 56 for these. So I'm gonna get those into place, and then I'm gonna focus my attention to the front panel. I'm gonna rework those boards up there, the LED indication board and the power indication board for the Class A light. And then I'm gonna put the front VU board in and then get the front faceplate on. And I'll update you guys when I get to that. Here's the new Chemet filter capacitors installed onto the daughter board. And here are the old caps that I removed. Funnily enough, these original filter capacitors still measured perfectly. They were a little bit down on capacitance, but not too much. They were about 9,000. So these are fine. But because of the age, I don't know how long these would have lasted in circuit, especially with constant use. So I opted to change these out. So here are the new ones, and I'm going to be reinstalling them in and moving to the front panel. More to come. Here's one of the last status updates. I just got the faceplate cleaned up and installed.
I polished the buttons, and I even polished the headphone jack. I cleaned up the VFD and the filters for it, and that turned out really well. Pretty cool. That nice warm orange glow of the new Class A light. I love that. I have the 2 new filters installed and soldered down, and I also have the bracket reinstalled. Overall, it looks really, really nice. I'm very happy with it. And right now, I'm just measuring the offset one more time, and we're right at about 1.3 millivolts. And here's all the parts I changed out. So the courtesy outlet, the lamp cord, the 2 speaker jack assemblies, the rectifier diodes, a couple of these open air carbon track trimmers, and all the capacitors. So all that's left is to throw the top cover on and take a listen. Should sound pretty good. I even have the wire loom re-zip tied. I have it all tied up, so it looks pretty good. All these little touches like this, you know, zip tying that and putting shrink wrap on the IEC inlet, all those little things that you wouldn't really think mean much, they all add up to a beautiful end product. And that's what sets good techs away from the bad techs that don't do all those extra steps. It does make a difference in the end. That and, you know, all the tools that are required to do a job like this. So let's get the top cover on and listen to some music. So I have the top cover installed, and I have the SE-A7 installed into my system. I've been listening to it for the past few minutes, and it sounds really, really good. I'm using it with a Coda FET02B preamplifier on a pair of Snell Type Q stand mount speakers. I'm playing some YouTube copyright-free music right now, just so I don't get another copyright strike from one of my last couple videos. So I'm gonna start not playing music that's copyrighted. Just go to YouTube's audio library. It's probably the best bet. So, but for now, it sounds really good. And the noise floor is dead silent, which is pretty cool. The rear I/O came out really nice too. Pretty happy with that. So yeah, this is a final product of a pretty comprehensive restoration. This amplifier didn't need any repairs other than some glue removal and some corrosion removal from that glue. It came to me working pretty well, so I just wanted to guarantee the stability of this thing for the next couple decades anyway. Still not sure if I'm going to keep this. I probably will for the time being. I might list it for sale eventually, but for now it's just too cool to get rid of. So I'm gonna end the video probably right there. I appreciate all the feedback I've been getting on these videos. It's really cool to see people enjoying these and getting some info out of them. And it's making me want to continue making these, so
I'll see you guys next time on the next one. See what else I could bring you. So, thanks again.